Hi, this is Module 1, Almost Primitives, of the Rhino Illustrator workflow. And we're going to be talking about these primitives to complete surface drawings and plane oblique drawings in this tutorial. So I have four geometries here that I'll be working with in this tutorial. So you can either work with these or design your own. Through this tutorial, I'm going to show you how to model these two right here, and then these two I have already modeled, and I'll show examples of how I have already drawn those as well as we work through those drawings. So the first step is want to make sure in this tutorial we're going to have our units set to inches and our distance display set to fractions. And then remember, whenever we set whether we set our file in feet or inches, that will impact how our file exports into Illustrator. So just remember that how you choose your export settings. So another thing before we get started, take a look at my layer settings and pause the video and set up these layers, and then remember just to double click to change the layers, the layer names, and then the line types, and then the print widths, and all of those will export to Illustrator whenever we make our drawings. And all that will help whenever you both organize within Rhino, and then we have our drawings in Illustrator. But all the layer names are pretty self-explanatory as we work through the types of drawings and diagrams we'll be making. And then also, while we're working through this tutorial, we want to make sure our viewports are set to shaded, rendered, or ghosted. Those are going to be the most helpful to show what we're working with. Right now, I have it in ghosted. You can click this little arrow right here, and it shows in ghosted. We can also go to view up here, and it shows ghosted right there as well. But now that I have my layers shown, I'm going to close this, make it a little bit smaller, and then you can always change the size of these as well. So onto solid modeling. We're gonna start by just making some cubes to make these geometries. So the first step that we're gonna make we're gonna make a cube that's 4 feet by 4 feet. So we're just gonna start off by making a rectangle. We can also just draw a box, but for this example, we're gonna just draw a rectangle, or we can also draw a polyline. Kind of like with Rhino, with what I was saying, there's multiple ways to do all of this. So in this example, I'm gonna go to top view, and then using the grid snap, I'm gonna start off with the origin, and then I'm gonna draw a rectangle, and then I'm gonna do 48 by 48. And then I'm gonna go back to my perspective view here. Then I'm gonna type in extrude curve, and then I'll type in 48 inches. And so then also, while we type in extrude, that'll make this a solid, but typically it will already have it as a solid in the settings. But if not, you'll see that toggle option here. So if it says no, you'll want to make sure that is set to yes, and then make sure both sides is set to no. And then you can toggle with these as well if you wanted to. These are just more of the specifics of the extrusion settings, but just make sure yes is on to make sure this is a capped surface. Everything that we're going to be doing, make sure all of our surfaces are capped and closed curves. We don't want to be working with open curves. And then we'll do 48. And there is our cube. So now we're going to make 4 copies of this cube. So we can just Control C, Control V. We can use the gumball to make copies of this. But another new tool that we can use is the array command that can easily distribute this cube evenly. So that way we can evenly make clean copies of this cube. So to do this, we'll select it and then type array, and then we'll choose 4 in the X direction, and then hit enter. Hit enter for the just 1 in the Y and the Z direction. And then for the X spacing, we'll just choose this origin point here. And then for the second reference point, we'll just choose, it's not to be anything super specific, but just however long you want it to be. You could typically just maybe go another like 2 major grid lines over. And then it'll ask you to accept what you chose, and you'll hit enter. And then that way you can easily order your copies of whatever you wanted to make. So that way we have these. We want to make these cubes into an interesting geometry, like into what I have here. So all of these are based off of a cube that I had. So we're going to model these off of subtractive processes to transform the cubes. So to do that, we will utilize 3D shapes and or extrude 2D geometric profiles and planar surfaces that can be used to split, trim, Boolean difference, and or Boolean split commands to edit and manipulate the original cubes. So split, trim, Boolean difference, and Boolean split, those are all commands that you type them in. Those are all commands Rhino can use to manipulate this geometry. That will edit how these cubes will look. So for the example here, I'm going to show you how to make this. So I kind of already have it set up here. So I kind of have it like in the process to show like how it works, and then I'm going to start it from scratch here as well. So you see, this is kind of like the in-between stage, and this is the final. So to start off, I want to make sure the OSNAP, your OSNAP and your status bar is on, which it doesn't show in my video recordings, but in your bottom screen, you'll want to make sure your OSNAP is on, and then your midpoint is on for your OSNAPs, and then you'll choose planar surface here, and then you'll draw a planar surface, and then you can choose the midpoints here. And make sure you do this in order, otherwise you'll create a twisted surface. And that creates what I just had here already. So you can either draw that again, or we can easily do is just select that. And then you can type in mirror. And then you can draw that mirror plane and easily mirror that over. So now what I want to do is, I have this pitched roof shape of this kind of like house typology of the shape of what I want to model, and I want to subtract this away, right? So in order to do that, I can type in trim and then select my cutting objects. So I'll select these 2 planar surfaces and then hit enter or hit the spacebar, and then select the object to trim, and I'll select those outside surfaces of the cube. So I'll hit here and here, and then hit space or enter, and then that is how the trim tool works. So after that's completed, this is still not a closed surface. So if I click and drag this, you'll see that not everything is joined together. So I'll undo that, Control Z, and then I'll select everything, and then I'll type in join, and that will show that everything's joined together. And then if you want to make sure everything's joined together, you can type in show edges to make sure that all your surfaces are joined together. So basically what you would want to imagine whenever you're modeling to make sure that your surfaces are all joined together is if your model is filled with water or some kind of liquid, you wouldn't want it to be leaking in any way. So you want to make sure everything's covered and there's no holes in any direction that would allow anything to get out. So right now, as I close this, there is no naked edges that show. But say if I undid that join, and then I show edges, it would highlight those edges here to show me that that there's nothing capping off the edges of those planar surfaces. So I'll go ahead and join those together again. So that's how you model this shape here. And then next we're going to model this half cylinder, half box slanted shape really quickly. So you'll see here there's multiple steps to this one, just really quickly. So first we'll just model a cylinder really quickly, and then draw some more of those planar surfaces, and then trim again to do that. And then for these, in the next video, the modules will talk about the Boolean objects. Okay, so we're gonna create a cylinder. So in this toolbar here, you can right click and then open up the cylinder. And then you can just create a cylinder from this endpoint here. And then you can ask you to create it from the radius or the diameter. So right now it's from the radius, but you can click diameter. And then you can type in 48. And then 48 again. And then click it, and then you'll want to have center turned on, and then you'll want to kind of click towards the edge, and that'll orient it towards the center, and then you can move it towards the center of the square. So now that we have that modeled in there, we're next gonna draw this one, this planar surface in here again. So there's multiple surfaces, so if it helps, you can create different layers for it, or you can turn them on and off, or turn off different turn off the different shapes as you don't need them. It's up to you, or you can work in different viewport modes if that works for you. It's just a matter of preference. So similar to last time, I'm going to just make it off the midpoints here. And then finally, I'm going to make one more. And this is going to just cut right through the middle of this cube here. So now that I have all this drawn, I'm going to now go to trimming. So first I'm going to type trim, select cutting objects, I'm going to select this one, and then I'm going to trim away this part of the cube to leave the cylinder, hit enter, then I'm going to type trim again, or hit the space bar to repeat the trim action, and then select the slanted planar surface, hit the space bar, and then select the top portion of the cube to take away that part, and then hit enter. And then we're going to trim one more time using that mid planar surface, and then we're going to trim out this cylinder. And then that is how we get this geometry here. And then we're going to, this time, to join everything together, I have the group toolbar for the Boolean commands on the side here, they're located here and here, but we're going to Boolean union this all here. And then join it together. And for the sake of time, I have these also ready to go. So now we have our 4 objects. And if you haven't already, make sure your file is saved. So just save it, and then now we're going to do a save as. So if you're working in Mac, make sure this will be a duplicate. There's not a save as, you'll just duplicate your file, and in Windows you'll just do a save as. And then whether you duplicate or save as, you'll save as DEV, or just call it DEV SF for developed surface. So this file that we're going to be working with now is going to be for our developed surface drawings, and then you'll go back to the old version of this file to make our plane obliques. So just go to File, Save As. I already had this file saved as, so just go ahead and do that, and then we'll go ahead and keep working from there. Okay, for our developed surface drawings, there are two methods, but both have the same end result. For method 1, we can explode our models here. So we can explode our models and use the rotate 3D command to manually unroll and unfold the surfaces until they are coplanar with the X and Y axis. Once this is completed, we can either use the set point command to move the objects to the 0 world C-plane datum of the Z-axis, or manually move the unrolled object in the Z-axis to a common Z projection C-plane datum. Or the other, and I'll show you both, but the other one is we can actually use an unroll surface command to have Rhino unroll and project the surfaces to a C-plane. If using this method, test the different outcomes when you explode, label, and keep properties. Unroll command will likely send the unrolled surfaces to the 000 C-plane world origin. And so just a note on these two methods, it's worth just trying out both when you're working with different geometries, because both kind of have their quirks and different complexities. But anytime you have a rounded curved surfaces, you will have to use the unroll command, at least on that piece of the object. So say for instance this curved piece of this geometry here, you will have to use the unroll command to get this piece flattened. And so what we're working towards is here, what I have finished, this is what our end result will be, is these unrolled surface drawings. And these ultimately are construction drawings of how these geometries are put together, showing how if you were to construct and draw these geometries, how you would put them together. So we're going to kind of undo that now, where we unroll them and flatten them, either by exploding them and rotating them, or using the unroll surface command. Okay, so first I'll just show you how to explode it and use the rotate 3D command, and we'll use these two for examples again on this one, just to kind of quickly go through this, just for the sake of time on these two again. So another quick thing I'll show you while I'm working. There's a shortcut whenever you're trying to focus on an object. There's a shortcut if you want to focus on a specific object. If you select it and then type in ZS, it's a shortcut for zoom selected, and it'll zoom in on that. So it'll target the camera around that, so it'll make it easier to go around that. So I use that a lot whenever I'm zooming in on something, so that's something I kind of just use a lot that you'll probably see me do. So you'll see me typed in that a lot. So I typed in on this, and so since this one, there's no curved geometry, I can just use rotate 3D. And so I'm going to basically just take this one apart and like rip it apart basically, but kind of just flatten it out. So I'm going to imagine this bottom piece is flat, and then take apart all sides. So first I'm going to type in explode, and then you'll see it's exploded into 5 surfaces. So each surface is now unique to itself. And then what's unique to rotate 3D is that you can rotate it to a specific axis, and that is unique instead of just rotate that you see on the rotate of the gumball. So you'll have to type in rotate 3D, and then you'll see the rotation axis. So in order to do that, I'm gonna actually select both of these surfaces, and then type in rotate 3D. And then I'm gonna hold shift here, and then I'm gonna hold shift again to flatten this. And so then that will flatten that out. So then I'll have to do that again to flatten this piece here. So now that flattened this piece. So we're gonna do that again. So now I'll have to rotate 3D this piece. So I'll hit insert rotate 3D again. I'll rotate 3D along this axis. This angle, I'll rotate along the angle of that edge, and then hold shift down along that plane here. Now I've flattened here. And I'm going to keep doing that for all of these pieces. Looks like this one's a little bit close. So I'm going to select this all and just gumball drag it over a little bit. I'll rotate 3D. And now this is a flattened developed surface drawing that we can take further here. So this one is different than the one that you see here. And so the methodology of what we're going to do is within the boundaries of each rectangle that we're going to draw, we're going to compose one of our unrolled models, and we're going to modify the arrangement of each unrolled surfaces while keeping all the parts connected along each edge. So the compositional strategy we should consider for each figure outline and relationship along the unfolded parts, and position each object within the rectangle, and then form these within the box. So basically, even though this is the same shape, this is still that one shape. There's multiple ways we can kind of think of how to unfold these. So I already have this one set up here, but in your process of doing this, there's multiple ways that you can unfold your shapes. So I did rotate 3D for method 1. For method 2, I'm going to unroll surface for this shape here. For this one, you do not have to explode it, you actually have to have it all combined. So this one I already do have it as a poly surface, you can see that here. And then remember, you can always do show edges, or something else you can always type in is just type in what, and it'll type in or show what the object description is, and it'll say this is a valid poly surface, closed solid poly surface. And so then I'm going to want to move this out of the way. And you'll see in a second, because it's going to create an unrolled surface right there. So now I am going to select this, and type in unroll surface. And then I am going to keep off explode, that way it'll keep all the geometry together like these here. And then keep labels off. You can keep labels on if you want. It helps for if you're making models or wanting to say like laser cut or make models where you have a lot of pieces and you want to keep track of what you're working with. And then you can keep properties on, and then you'll hit enter. and then you'll see here you have your unrolled surface. So you'll see that your curved surface is now a rectangle, but essentially it is still that rolled surface here. And we're going to do the same for these. So now we have all of these for our 4 objects. So then I'm going to walk you through now how to set up these line drawings for how to get to this step here. Okay, so the next part of these drawings, I moved to my top view. And so, as you can see, these drawings or these surfaces get pretty big because these are all mapped out here. So the original ones you'll want to move out of the way. And the reason why we made those copies of the files is because we're unrolling them. You'll want the original copies. As you can see, I don't have the original anymore because I unrolled it out. So we'll move these out of the way here. This is just using the gumball function here to move these along the axis here. And so now that we have our 4 models unrolled, we're going to and all of this we're still modeling with our surfaces in this modeling surfaces layer. We're going to draw 4 rectangles, and they are going to be 272 by 352. And you can see they've become quite large here. They're the size of these. And you can do the same thing as last time, where you can array them if you would like to have them even. But no specific like distance constraint in between them, as long as they're just kind of evenly spaced out, just so they're nice spread out. So now we're going to place each of these into these boxes. This is all just using clicking and dragging. But if you also wanted to move, you can also just type in move, and then you can move these accordingly with that. So I have these. So once we move these are, once we scale these and export, these are essentially becoming our artboards that we're going to be working with. And these are going to become our pages, these borders here. So think of these as if these are going to become your 8.5 by 11s that we can print with. So now that we have our unrolled surfaces, we have our boards. We're going to switch to our modeling lines layer, so we can switch that current layer to here, and then we're going to select all the surfaces, and then there's multiple ways we can create the lines. We can type in dupe, and dupe is short for duplicate. We can type in dupe border, dupe edge, or extract wireframe. All of these are going to execute the same function to extract or get these lines. So, for example, I'm going to turn off the layer, and you'll see what you end up with. And this is the final result that we'll get, where all we have is just the lines that we the lines now or the surfaces disappeared here, but all we'll have is just the lines. Also, to create our lines, you'll see that these surfaces are actually still joined together. So first we'll explode these surfaces, and then we'll move forward with making, we can either dupe border, dupe edge, or extract wireframe, but we'll dupe border. So we'll select the 4 unrolled surfaces, and we'll hold Control to deselect those artboards, and we'll type in dupe border. And it says duplicated 35 borders. And as you see, if we turn off our surfaces layers, we're left with our lines here. Also, we're gonna turn this layer. We're gonna add this to our depth points layer. So that way, when we turn off our surfaces layer, we're just working with these here. We're just working with our lines now. No more surfaces. So moving forward to our final steps in Rhino. So we have our lines now. So now we're gonna work on organizing them. So from here to here, we're gonna draw some construction lines. We can use arc or control point curve, or curve through points, or curve interpolate points to notate important construction connection points between unrolled parts along the perimeter. And then you can also use edit point on to adjust these curvatures afterwards. So for example, like these points here, after they're unrolled, to show those construction lines, you can just draw an arc between those. And that's just to show those construction lines. So to start off with those, any one of those commands will work. I prefer this one here, the interpolate points, to have a better handle over the lines. So we'll go ahead and work with the layer for that. So we'll switch to the construction line for that. And then any point to notate important connection points along the perimeter, you'll just draw those lines. So we have those drawn now, and then we can always just click on those lines to handle those control points of the geometry to make those look a little bit more controlled here. So we have those drawn, and then now we're going to organize the layers more. So we're going to assign the layers. So we have those rectangular boxes assigned already. And then next we're going to assign our profile layer. So the easiest way to do that, we're going to quickly, we're going to switch to this layer now, and then we're going to switch to our profile layer. We're going to turn off the construction layer, and then turn off the depth points layer. And then we're going to select all of these and explode them. So now we have individual segments, and then what this did is it created a bunch of little segments, and then you'll see it has duplicates now inside of here because there are overlapping geometries of the same rectangle inside here. So Rhino has a super helpful command called select duplicates, and it's cell dupe here, and it'll select the same exact lines, geometry, surfaces, and it'll select those for you, and then you'll go ahead and hit delete when those are selected, and it'll get rid of those for you. So once you do that, you can go in on the inside here, and actually we're going to go to our minor or our seam layer now. And then any of our inside seam lines now that we see like this here, for our example of our previous one, or of the same objects, we're going to switch to that layer. So we're going to just select these using using Windows to select these lines. It's a little bit hard to see with this color, so I'll probably have to go back and select some off of that last one. So you'll see I'm just going down the inside and selecting all of the interior lines, all the minor seam lines. And I'm holding shift while doing this to select all of these. And then I'll right click and then do change object layer. And then let's see how I did on this one. If I missed any, looks like I did this one here. These. And then we'll add these as well. Change object layer. Change object layer. So we have those set up. And then what we can easily do now is now switch back to our profile layer that we're about to use and turn off that seam layer. Oh, okay, we're actually going to need, looks like we need these here. So it looks like we need this outside edge here, but we don't need this whole thing, right? So we're going to use split. So I'm going to type in split, and then I'm going to select objects to split. I'm going to type in this, select cutting objects here. So now this object is split. I'm going to do the same thing for this one. So now all of our interior lines are gone. We should be left with is just our profile lines of this or whatever you modeled. And then we'll just select that, and you should type join, and then it should say 4 closed curves of whatever you modeled, and then you'll switch that to your profile curve. And then turn everything back on, not your surfaces though, and then actually, looks like these are a different layer here. We'll switch these profile, that's my mistake. We'll switch these profile curves. So we'll do select objects. We'll switch these back to this modeling lines for consistency. And then now these match these here. Now these are good to go to export. So just to go over what we did, we have our outside or profile lines drawn. I still have it in this layer, but it is the same thing exactly as the profile line, but we're going to use a profile later on. We have our construction lines, our inside or seam lines, our artboards, and we're going to use both of these. And then we have our surfaces that we worked on later. That's all turned off, and we're going to keep those turned off. So now these are all lines, and we're going to be ready to scale and export this from Rhino to Illustrator. And so there are times when you can do all of your line weights and printing directly from Rhino, and you can practice that, but you can also process all the scaling and exporting to Illustrator, and assign line weights and colors in Illustrator as well to practice your presentation and drawings and so forth. And all of that is just really good practice. And just with all of that good practice, there's a lot of troubleshooting in both using a Mac and a PC in dealing with line weights and exporting. So depending on if you are a Mac or PC user, the process of exporting from Rhino to Illustrator can be very fussy depending on which version of the software you're using. So just some tips if your file is exporting or not opening. Um, and we'll talk about this a little bit more in Illustrator, but do a select alt in Illustrator to make sure your lines aren't white. That way, like, you make sure everything is being selected and that it's not being invisible. And then whenever you're exporting from Rhino, um, make sure the line where you're trying to export is close to the origin. That way, whenever you place it in Illustrator, it's not way off your artboard in Illustrator. And then, like I said earlier, just double check your units in Rhino and in Illustrator and make sure those match and the scale of that as well. And then also, excuse me, when you open a DXF file in Illustrator, if some layers import and some others don't, it could be that you have a layer not set to print in that Rhino layer menu, such as depth points. Often these will not export until you change that setting, close out, and save in Rhino, then reopen and export again. If that still doesn't work, create a new layer and then move that line work over to that layer into an existing layer. So they're just some tips, and then let's go ahead and export. So to export, we are going to take all of these. So I already had the example of the scaled here. So I'm going to take, moving this down. So I have my 8 drawings, or however many drawings you have that you're working with, and you want to move them as close as you can to the origin that you're working with. And then you'll type in the command scale, and then the base, you'll just type in that close to the origin, and then you'll use a scale factor of 1/32, and then that will automatically scale that. So you'll see here, whenever we type in distance, the command distance, this is automatically scaled. That's 8.5 inches by 11, where this is ready to go, where if you place this in Illustrator, this is a sheet of paper. So, say for like in this example, if you wanted to just print on a sheet of copy paper, this will be ready to go. So this example that works for a sheet of paper, but a lot of times you can use for any type of scale factor, sheet of paper, lots of times a lot bigger than that, and so on from there. So we're going to make sure this is close to 0, 0, and it already is. You can get as close as you can. You can move it to like a corner like this. It's kind of just preference of like in the center and so on. And then we're going to now go to exporting. For this example, we're going to export in the DXF. It's also called the AutoCAD DXF file format. So we're going to go to File. You're going to select everything that you want to export. File, Export Selected, and then you'll choose wherever you want to export that. And then you'll want to choose that file type. And then AutoCAD Drawing Exchange, it's the .dxf. And then I already have one of the examples I had here. So module 1 export df, I'll just name that one part 2. And then options, there's 2004 polylines or 2007, whichever one. A lot of times those tend to be the best way to preserve the joined lines created in Rhino and your layers. So DXF tends to be kind of one of the main standards. AIs are also pretty common to be one of the most common export file formats. CWGs are common as well, but DXFs are also just one of the main common ones when doing these kind of drawings. So you'll just do DXF and then save it, and then you'll hit OK, and then you are good to go, and then you'll save this file again, and then you are good to go, and then open up your file, or open up a new file in Illustrator, and we'll get started in Illustrator. So I have Illustrator open. I opened up Illustrator, file new document, and then I did a new file format with 8.5 by 11 and made it with 8 artboards. With my screen recording, I wasn't able to show the dialog box, kind of like with the exporting options. I wasn't able to show exactly how the exporting worked, but I can still show how it worked here with artboards. You can see our artboards here. You can order them and then add artboards, and then click the artboard tool here to see the size of them and so forth. But once you have the size set up, it's pretty self-explanatory. And then all you have to do is go to File up here in the top left corner of Illustrator, and then Place. And then wherever you saved your DXF file, you'll click the DXF file, and then click to place your DXF. And then there you have the DXF drawings that you made. So mine came in a little bit smaller, but first thing you want to do to make sure that your file is set up is that you want to make sure all your lines are 100% black. So in order to do that, you want to go to the color, and then click black here, and then you can also click here, make sure it's CMYK, and then go to 100% black, turn all these off, so that way it's just 100% black. And you can already see here that you can see the difference in your drawings, and these look like architectural drawings now. And then you can see the line thickness of the profile, and then the super light thickness of the construction line drawings of the arcs, and then the minor line thickness of the inside seams as well. So now we'll just go ahead and work through organizing these onto the artboards, and then we are good to go to print these. So each one of these we'll just select. Actually right now, once we place them, they're grouped. So we'll go to Object, Ungroup, and then the shortcut is Shift Control G to ungroup them. So ungroup those, and then we'll select and then drag and place each of these into the corner. And I'm going to go ahead and do that for all of these, and then I'm going to do that for each one, and then scale that to their full scale size. And so now we have all 8 of our drawings set up to print. And then one thing also, zoomed out, the arcs look very heavy. That's just the screen resolution. Once you zoom in, you can see that they become very light. And that's something that you'll work with as you begin working with digital and then printing, that you'll get used to seeing how it looks on the screen, and then you'll print it and see how it looks both on paper as well. And then also, once you have those lines, you can also, those boxes, you can delete them as well, because those boxes are there to help you align your artboards. So you don't need those, you can delete those, but otherwise you have your 8 unrolled surfaces, and then we'll move towards the plane obliques of those objects that we made. So now we are back to our original file with our 4 objects that we're working with. We're going to be working with our plane oblique views with these objects now. So our plane oblique views, this is what they will look like. Over here, this is what our final product will be. We're going to make these types of projection drawings with the objects, and then eventually we'll get to this point here. So we'll get to these types of line drawings here. So I have this over to the side, so we'll get all the way up to this point here, where we'll get to this type of projection here. But first, we have the original drawings. before we had the develop surface drawings. So we'll go back to our perspective view, or whatever viewport you prefer to work in, and then we'll do another save as or duplicate your file you're working with, so that way you have a new file. That way you can always go back to the file of these four objects, and then go ahead and we're going to make 4 copies of these objects. So we can do array, and then we'll do that in the y direction. We'll do 4, and then y spacing, we'll do the reference point here, and then we'll do 140, and then we'll hit enter to accept, and that is our spacing here. So that looks pretty evenly spaced. And so what we're going to try to do now, in order to create different views of these objects, we're going to use the rotate command, or we can gumball to rotate each object in different angles. And then we're going to rotate all of these objects using the rotate command or the gumball. And we'll rotate these one by one, but it'll become pretty quick using gumball. So we'll be going row by row, and we'll be rotating them around the z-axis. All we have to do is by pressing the blue arc here, we'll be typing this row. This first row will be 45, so we'll do 45, and then we'll just type or press it in again, 45, 45, and 45. And then the second row will be the same thing, or same axis, but we'll do 135 on this one. And we have those. And then next we'll have a 225. And lastly, 315. That one I hit the wrong one. So you want to be making sure you're hitting the right arc. So there we have our different angles set up. So there we can see we have set up a northeast, southeast, southwest, northwest, different projections. So from there, we're going to draw a 50 by 50 square, just right here by the bottom square, and then we're going to just do this in modeling lines layer. So just 50 by 50. And then we're going to rotate this 45. And then next, we're going to select all of our geometry here, and then rotate it a negative 45 degrees around the x-axis, which is the red line. So we'll press this one here and type in negative 45. And then if we maximize our top view, we can see that this becomes a plane oblique view, kind of like what we see here, and almost final to what we see here. So now this is ready to go for our Make 2D. So we have this set up. So we're going to select all of this, and make 2D is a command where it'll um, take all of your geometry and whatever geometry you have, it'll make an outline of it, make 2D. And so I hit that command, and so for my software, like I've been saying, the dialog boxes haven't been showing up, but it says 2D drawing options. And then my options I'm going to select, it says view. I'm going to keep it with top projection. I'm going to say view. Object properties, I'm going to keep it at maintain source layers. And then the options I want to keep on, I'm going to make sure hidden lines are on and scene silhouette is on. Scene silhouette is often called the profile as well, and that's kind of like what we call the thicker profile here, which is like the outline of the silhouette. And then we will keep off the tangent edges, viewport rectangle, group output, and everything else. And then the layer name we'll just keep as make 2D. But the two crucial ones are hidden lines and scene silhouette. And then just make sure you keep maintain source layers on. That'll help you organize all of your make 2D layers. And make sure make 2D is just very clean and your output's very clean as well. So we'll go ahead and hit OK whenever your make 2D box shows up. Hit OK, and then you'll see that it loads. And then you see here the new layers are formed, and then you have your new make 2D. So you see from what becomes surfaces is now just lines, like what we had here. And then our next step is we're going to draw a horizontal line across from here, and then rotate it 90 degrees, and then pull it up here. So we have this line that we drew, this square, and then we're going to use a scale 1D command to scale our plane oblique to make a 45-degree bird's eye plane oblique that we have from 45-degree vantage points. So we're going to select all of this and then type in scale 1D, and then base point here, and then we're going to do from the top of the square to the top of the line. So here, I'm going to zoom in a little bit more so it's easier to see. From here to here, we're going to scale that. And now you can see that we have scaled our plane obliques to match what we had here as well. And now we have our plane obliques, and these are ready to go for our layer management for our final output into Illustrator. So the last thing that we're going to do for this is you can move away these rectangles if you want. Just organize this however you like. Turn off your surfaces if you don't want them on anymore. But the key thing now is you're gonna draw 136 by 176 boxes, and then you will organize your object drawings into that, and then also you will assign the boxes to the depth points layer, and then the outside profile figure you will assign to the profile layer. So that will be available in the scene silhouette. So if you select objects, you will see that that profile is available in the scene silhouette layer, and then available in that modeling surfaces. So it's in this sub layer of the scene silhouettes layer. So if you can do it won't be available in this layer. This is only a subset of the visible layer. So you have to select this one of that scene silhouette layer. Select objects, and it'll select all of these, and then you can move that to the profile, and then you will have these, and then these will already have these thick and ready to go for Illustrator. And then you will move on to your other line management, similar to what we did with our develop surface drawings. So we're going to have our interior lines that are going to be minor, but still thin. So these are going to be like our seam lines here, but still considered important to the drawing that make up the geometry. So we're going to select all of these that are the visible curves because they're still on the outside of the geometry. So we can select all the sublayer objects of these and change these to this layer here. And finally, we have all the hidden lines that are behind what was visible to the geometry, and that is available here. And then we'll change that to the dash hidden. And then there we have our layer management of our geometry. And then we will go ahead and organize all of our geometry into boxes like this. And then that is module 1. And then from there, we can also assign any construction lines or any other virtual information that we consider important to the construction layer if we deem necessary as well. And then we can scale the drawings as well. And then from there, we can export that from Rhino to Illustrator, and then edit the line weights from there, and then save and print that as well from Illustrator, similar to how we exported the developed surface drawings. So whenever you're ready to export these and you have these scaled, you'll select whatever you had ready to go on your artboards, and then you'll want to move these closer to the origin. And then you'll go to File and Export, and then you'll export those as a DXF with the 2004-2007 polygon lines, and then place those into your artboards in your Illustrator file. And that is module 1. So I've placed my DXF file in Illustrator, and then like last time, remember to make sure that all your lines are completely black, and then change your line types if necessary, but otherwise if you did that in Rhino, and then place your DXF file, edit your lines, and then take out the artboards if needed, edit your artboards, and then organize your file, and then you are good to print.